Good afternoon.
Hi.
Sorry, they were trying to put me under house arrest or something. I don't know. My name is Lamar Coffin. I suppose you saw me this morning. I'm just curious before we start, how many of you have used GeoGebra at all? So just a few. Okay, great. And of those you that have used it, how many of you have used it extensively and have made some cool things you can share with us? Awesome. Just a few. So I thought, I really have no idea what we're going to accomplish in 1 hour. Probably got overly ambitious. Did everyone get a, sorry. Here's sort of a handout of what's happening during our session today. Thank you. I'd like to take about maybe just 10 minutes and just sort of explore what this can do. I mean, there's no way we can learn GeoGebra in an hour if you've never seen it before. But it's fairly intuitive, fairly easy to kind of pick up some basic things. So we'll play around for about 10 minutes, do a little bit of explorations, and then if we have time, have you create some of your own sketches that could be used in the classroom, or at the very least talk about how you could use this in the classroom, how it could change the way people teach math. So, does everyone have GeoGebra up on their computers? Supposedly you downloaded it before you got here. If not, go to geogebra.org and just download it. Doesn't take that long. So on the top here is the toolbar. This, of course, is your select tool. This is your point tool. And notice when you click on each of these tools, you have all kinds of options. So say you want to draw a segment between 2 points. You click the segment tool, and notice over here it says segment between 2 points. You click this, and then you select your 2 points, and it makes a segment. So let's just do a point. Select your point tool, and let's just do a couple of points, just so we have them on here. Notice it labels them automatically. You can take the labels off or change them if you like. And now suppose we want to draw a line through, or a segment between 2 points. So choose the segment tool, and then it says select 2 points, select B, select C, and you got your segment. So it's fairly intuitive. Any of these tools, if you're not sure how to use it, when you click it, it will tell you what to do. Just to show you some of the, if you want to draw a perpendicular line, or a parallel line, or a perpendicular bisector, or an angle bisector, you can make circles with the center through a point. You can do a semicircle. You can make polygons, regular polygons. You can find the angle measurements of any given angle or polygon, all these different things. I won't go through each one because the activities we do, the steps will be listed step by step, so you can actually follow it fairly quickly. So why don't you take about maybe 5 minutes and just play around. Choose some tools. If you are familiar with it, if you could sort of look around and see if anyone's having trouble, that would be great. So just play around for about 5 minutes and see what you can do with those different tools. There are sorry, I forgot to mention this. There are several views that you can also choose. This is the graphic view, and this is the algebra view. Anytime you create something in the graphic view, there's an algebraic correlation over here. So if you create a line, it will give you the equation of the line over here and name it. If you create a point, it'll list the point and its coordinates and all those things. So play around. If you're stuck or have a question, let me know. A dependent object is when, what is this? I'm not sure what A is. Oh, okay, so these were free objects. I freely created the points. But then this segment was specifically created between points B and C. So this segment A is now dependent on B and C. So if I change either B or C, oops, when all else fails, go back to your select tool. If I change B or C, notice that A is dependent on that.
A is the length of that line segment?
Pardon? Yes, A is the length of that segment. So if it's dependent, you cannot change the value of it unless you change the independent objects which created it. Very important tools up here, undo and redo, very useful. If you do this to your kids, it will get this silent in the classroom. Well, they figured it out. It's pretty cool. If you want to delete something, you can just select it and hit delete on your.
Hold down command.
If you want to get rid of the axes, you can just right-click on the graphic view and then check axes. For example, can't do it on here. Can't do it with the smartboard. If you just right-click, or if you a two-finger click with a Mac, go to graphics view. If you hit axes, the axes will go away. If you want the axes back, just click it again. If you want a grid, hit the grid. Okay, I think for the sake of time, we'll move on. I'd love to let you play for a long time, but let's just do a really quick exploration. I did this with, I've never taught geometry actually, my whole mathematical career, but I did a credit recovery after-school geometry class this spring for kids that, just sort of New York City's way to pass kids through really quickly with a minimum amount of work. But I did this particular exercise with the one kid who came after school for the credit. And it was really cool. He really enjoyed it. He actually picked it up really quickly. The circumcenter of a triangle. I don't know how many math people, or like it's been too long since you've been in geometry. But if you have a triangle with 3 points, the circumcenter of that triangle, if you take a circle that, I can't do this very well, that includes those 3 points, the circumcenter of the triangle will be the center of that circle. Right? And it's created by taking any random triangle and doing the perpendicular bisectors of each side. And the intersection of those 3 bisectors is your circumcenter. So, I'd like you to try, just using the tools that you played around with, if you can, to create the circumcenter of a triangle. The steps are listed for you if you want to just follow the steps. If you want to try it yourself, you can. There's a perpendicular bisector tool up in there. There's a polygon tool.
What's interesting about that particular choice is that
I should have run it, so I didn't get the circle that's supposed to be perfect.
How are we with our triangle? Got our circumcenter?
Yeah.
So, and as I was doing this lesson with this kid, I was saying, okay, so pick any point on your triangle and drag it around and watch what happens to the circumcenter. Of course, at first it's inside, then you drag it around a little bit, all of a sudden the circumcenter goes outside the triangle. Sometimes it can lie right on the edge of the triangle. The question is, why is it doing that? What conditions create it such that it's inside, such that it's outside, or such that it's lying on the line? So if you don't know the answer, play around a little bit, see if you can find it. Drag one of your vertices and look at the angles if you're not sure. It's a hint. Oh, you have to, okay, so, sorry. If you want to create that circumcenter, you choose 2 of the perpendicular bisectors and do this, the tool right here, the second one from the left, called intersect 2 objects. GeoGebra only intersects 2 objects, not 3, so choose any 2. It'll create the point. Or click that tool and then click 2 of the bisectors. So, any observations? What kind of, actually you had an observation, go ahead, say it loudly for the group to hear. Suppose we want the circumcenter to lie on the side of a triangle.
On the side or?
On a side. Like so that the point, the circumcenter, is actually lying on a side of the triangle.
It will always be the center of that segment. So when you first had it, the line that was running through one of the lines also ran through the right section.
Right, okay, so he observed that if it's on the side, it will be exactly in the center.
Not necessarily.
Not necessarily.
Yeah, but if you pull it back to your right,
Uh-huh.
so that line now runs through B, and the line, yeah.
Oh, that. Oh, boy.
Bring it back up and have that. Sorry,
Joys of technology.
Yeah. So now you have this scenario where all three vertices, if you bring it back down through the center point as well.
There we go.
Right, now you have a scenario where all three vertices are equidistant from the center, so it's fundamentally it's the center of a circle where O to C, O to B, and O to A are equal, and they're all common radii.
Which actually is the definition of circumcenter, because by definition, the circumcenter is the center of that circle that inscribes all 3 points. It's when it's a right triangle, right? And you can drag it around. Anytime one of your angles is a right angle, your circumcenter will lie on the side. Yes, the opposite side, actually. So if you, let's see. I get this guy to be about 90 degrees. And you can set this so that the decimals go away, but there again, it's on the side opposite. When does the circumcenter lie outside the triangle? An obtuse triangle. And of course, if it's an acute triangle, it will lie inside. So it's a great tool for the kids to play around with and to sort of figure that out for themselves. And
but I think there's figuring it out, but I think there's a component part here that sort of got short shrift earlier.
Mm-hmm.
It's the posing of the appropriate questions.
Yes.
It's still a pedagogical.
Exactly. And I think that's the whole point of this workshop, is not just because the technology is up and they can play with it doesn't mean teaching it well or teaching it right. I mean, anytime I do a sketch, I put a lot of thought into what kinds of questions in the accompanying worksheet that they have to follow in order to figure out what it is. Just for the sake of time, let me see. I was actually playing around with this weekend. I got all excited because I have always taught, I mean, in New York State Regency exams, parabolas are basically in vertex form. That's the important form to know for the exam, so I teach it in that form. And I mean, the standard form, is used in factoring and things like that, but we don't play around with a whole lot. So I was playing around with it. It's like, you know what, I've never actually explored. I mean, I know that C, when you change C, it moves the parabola up and down, those of you mathematicians. But I was like, and I know that these two like sort of move it in other ways, but I wasn't actually never really studied how or exactly why. So I did this. I created this function, this parabola, and I set B to a certain number. I created sliders so that I could slide. Oops. Did not want to take a picture of that. So if you slide A, you can see what happens to the parabola. And I created the vertex at the extreme of the parabola and set a trace on it. And notice that sure enough, when I do that, it forms a line. Then my next question was, what's the slope of that line? Turns out it's half the value of B. So if you change B to a negative number, it becomes a negative slope. And then of course I said, well, what happens if I set A to some particular number? Doesn't really matter what it is. And then put the trace on B and slide B around. The vertex now follows the path of a parabola. What's the equation of that parabola was my next question. So it's actually really cool. I mean, I'd never really studied that before or cared about it or worried about it. But just playing around with this on my own, it was like, what would happen if? And I think that's sort of the cool thing to get our students. You can't do that every day. You'd never get to the state exams. But there are times when you can approach this, and kids will say, what would happen if? I've even given them sketches, like pre-made sketches, and they're like, well, can it do this? Can you make it do this? And I'm like, I'm not sure. Let me go figure that out, or like you try and come up with it, and it becomes great. All right, so I think what I'd like to do next, since our time's already almost half gone, I'd like you to try to create a sketch following these step-by-step instructions that were just, Nina will hand them out to you. There's a whole list of possible activities you can do. Many of them are in the packet that Nina's passing out, so you can follow the steps step by step and create your own sketch. And as you're doing it, I want you to think about if you were creating this sketch for your class. Actually, let's just go to the second to last page at the task part. If you want to do that dynamic parabola exercise I just did, the steps are listed in the worksheet. If you want to play with that instead, that's fine. So I'd like you to work alone or buddy up with somebody and create a dynamic interactive worksheet that could be used in a mathematics classroom. Most of these suggestions can be found in the activities section of the Introduction to GeoGebra packet, which is downloadable at that website, or the activities listed here are copied in that packet. So you can just choose one of those activities, program it in, play with it, see what happens. Or you can come up with your own. Those of you that have experience with your own things, or feel free to share at the end of the time what some things you've come up with. And as you're doing this, I'd like you to think about what kinds of questions, sorry, I don't know your name. As he was mentioning earlier, what kinds of questions would you ask if you were presenting this sketch in your classroom to teach this concept? How would you lead into, what kinds of questions would you ask the student to help them understand or help them go through this concept? When you were creating this, did you come up with any what-if questions in your own mind? Like, what would happen if I did this? Or this sort of leads me to this. I wonder what would happen here. Think about that. How would you differentiate this activity for different levels in your classroom? Because that can be a challenge. Are there any pitfalls that you can see using the technology? And then what sorts of extended explorations could you possibly build into the sketch, even if you don't have time to create it today, obviously. So the steps are fairly simple. The more basic ones are towards the top of the list, so if you're not comfortable with the software, choose one of those. I am on the second to last page. It's just a list of suggested, on the first handout, yes. The second handout lists all the activities and the step-by-step construction of them. Okay? So if you have trouble with the buttons or not sure where to find the buttons that are there, something doesn't work for you, let me know, or ask each other. So it's just sort of your time to play around, try to make a sketch, something you think would be fun, interesting, you'd use. Yes?
Does the tool allow for, does it have a word processing capability?
You can enter text. Where is it? Yes. There's a button. There's an insert text button under the, it's right beside the mover button. So if you insert text, if you just click on the screen and then you can put in, and these formulas here allow you to input like fractions, vectors, segments, those kinds of things. And you can, there's buttons here for squaring, pi, e, and infinity, all those things.
What I found most helpful in environments that allow for text components is that you get a much better sense for what the child knows or doesn't know.
Yeah.
By asking them to actually not write about the steps they took, but what does the mathematics mean?
The cool thing about GeoGebra that Sketchpad sort of has, if you just go backwards through the undo, redo, but it will actually capture all the steps you took. So you could actually have students, if you want to get their sketches from them, upload them to the web or whatever, you can actually go through a student's sketch and see exactly the steps that he or she took to create what they did.
Yeah, are there syntax issues with the,
With-
with the minus, negative, the graphic calculator, for example?
I don't think so. I use Sketchpad, so this I just learned this summer. I have not used this extensively enough to know that question. The resources on the website are pretty extensive, and it'll give you a lot of information on that. So I'm going to trying to turn my iPhone into a webcam so everyone can see the sketch that we're talking about, but it's not the greatest webcam, but hopefully you can see a little bit. Would anyone like to share what they made? Or I'll pick on somebody. Go ahead. Sorry.
You know, it's scrolling automatically.
Okay, can you see that okay? All right, so talk to us about that. What's going on?
Well, I was trying to remember how to do Fourier expansions, and I couldn't quite remember how, so the formula's not quite right. But you can see this slider here, as I pull back and forth, it increases the number of elements in the Fourier
yeah.
function, so it
Yeah,
gets
yeah.
less less and less woodgy as n goes up. And then there's the n equals 1 version of that, where you just have the one sine wave. And the way I did that was I used this thing here, this object properties toolbox, and I was able to use the sum function and the sequence function
Okay. Yeah.
to define. And I used a slider for big N.
Okay.
So you drive big N back and forth. And so you can do these sigma expansions using GeoGebra.
Okay, great. For the microphone, because they can't hear it in the recording, he created a graph of Fourier series using some sequence,
Yeah. So
advanced mathematics stuff. So
if you right-click on the dependent object, or you just type in the dependent object, you can sort of see on the object properties. But that's where all these commands in the lower right-hand corner. I saw the commands in the lower right-hand corner and said, oh, guess what? You can do sums and sequences. I wonder how big of an expansion I could create and what other programming type meta things I could build.
so if you're using this in the classroom, how would you use it?
Well, mostly I wanted to see if I could, if I was thinking about it, I used to teach electronics. So,
Okay.
you know, approximating square waves using sines, and then talking about this is the ringing you get when you have a, what's it called, an inductor circuit at either end.
Okay.
And so the more elements in the circuit, the less ringing you get. But it's never quite perfect.
Okay, cool. Questions? Oh, go ahead. Okay.
So I just inputted an equation of a circle, well, ax squared plus bx equals 1, and made sliders, and you can kind of go through conic sections by, starting to vary the slider. And what's nice about it is it's a pretty forgiving program. It doesn't stop the lesson, because a lot of things you do will work. And so that's one thing I really like about it. You don't have to put it in function, f of x equals. You can actually put it in. It's not a function. It's a locus of points.
Yeah.
And it's just a really forgiving program that doesn't impede the lesson and stop the momentum of a lesson. So, and it also lets them see generalized structure that makes them be able to abstract. It's a very great program. I love it.
So if you were, say, for example, you were presenting this as a lesson in your classroom, what kinds of questions would you ask your students as they played with the sliders?
I'd be first of all asking what are those different conics and how is it changing the overall equation? It's going to the x squared minus y squared form. And you could have huge discussions why.
Yeah, yeah.
And
Yeah.
and it's really, I've noticed these types of things make lesson planning easier. It doesn't have to make it more complicated. I walked to my class with just this one equation on a piece of paper, and I have an hour, 50-minute discussion.
Yeah.
And then I go into some maybe hands-on problem solving of actual little drill afterwards and see,
Yeah.
but it's really neat.
It was interesting you said, I've noticed this when I have something on the board that's moving or that's dynamic, the kids will always ask, why does it do that? They want to know why. If you just tell them on the blackboard, they may or may not care. But when they see it moving, or if they can play with it themselves especially, they were like, why does it do that? They're like, oh cool, it just did that, what happened?
And if you're
Sort of
teaching
changes
like
the dynamic.
Pythagorean theorem, anything you're teaching, you Google Pythagorean theorem, GeoGebra, you're going to get dynamic web
That
sheets
you can cut and paste.
Yeah.
show you 4 or 5 different proofs of the Pythagorean theorem and you can create them too,
There's the GeoGebra wiki, and at the end of the worksheet you can actually upload your stuff. I think we won't today for us just because we didn't have time, but you can actually upload stuff and have your class access it, or you can look at everything else that anyone else in the world has uploaded on that site, and there's a lot of really cool stuff on there, stuff that I wouldn't be able to do. Anyone else?
Yeah, well, what we did was we took
Here, hold that there. I'm going to hit my computer because it...
Oh, well, close it.
We took your function for the and but if you pose the question of what condition will the parabola be allowed? So when you set a to 0 and b to 0, then the parabola is a line that's horizontal, parallel to the x-axis.
Yes.
And runs through the y-axis at the value of c.
Yes.
So as you vary c, then this line goes up. So sort of asking,
Right.
what do you do as you?
Okay, you took it away? Okay.
But what happens, not just as you vary these things when they're all there together, but if you sort of set 2 to 0 and now what does the function actually demonstrate? And you can go back to the actual function and sort of say, why does this now default to an equation of a line? Because the a times x squared becomes 0.
Becomes
so
0.
now you have an equation of a line, and then to sort of work up from the equation of a line
Right.
into the parameter.
That's one of the cool things if you have this interactive software is that you can ask all these questions in a fairly short amount of time, and they can answer the questions pretty quickly because they see it right there in front of them. I often, when I first started using this, not this, but Sketchpad, I had the animation on the smartboard with the questions accompanying it. And so they just like looked at the animation, tried to figure out what was going on. Now, if I would do it, I want them to actually create the parabola, create the parameters, slide it themselves, and answer the questions. It makes a big difference.
I did notice that. Have you ever done this on a rational function?
No,
It doesn't show the
doesn't show the
vertical
asymptotes.
It's like so when you move it.
Oh.
I was hoping that it would also show.
Could you graph the vertical asymptote and have it?
Yeah, but it's a dependent variable.
Yeah.
It's a dependent object. It's not going to move
So it's not going to move?
unless you move it.
I'm sure you could just create an equation x equal whatever the parameter is, and it doesn't. Okay. All right. Okay, we have just a couple more minutes. Is that it? Okay. Is that clock wrong?
No, but they have.
Okay.
So for all of those, thank you, Lamar.
course.
And thank you.